Okay, so today we're focusing on translations, which is a slide, just from one location to the other. You can move it up, down, right, or left, and then technically with the diagonal, we're just moving it like right and up, like that. When a figure is translated, it will still be facing the same direction, so it's not being turned or reflected or anything, it's in the same orientation. Okay. So the next part here, it says, suppose you're given triangle ABC and are told to move or translate the triangle. How do you know how much to move it or in what direction? Well, there are instructions, which is called a translation vector. It can be used to describe the direction and the distance. Direction and distance that your shape is moving. So a translation vector can be visually, so you could have an arrow which shows like the direction and the distance, or it can be in numbers like this, -2, 3, which would be to the left 2 and then up 3, which we'll get to in a second. Okay, so the first example, it's showing you visually what a translation vector will look like and how it works. So here it shows the vector, and so this arrow means that the shape is moving this distance in this direction. So just like with the reflection, essentially we're moving each point that distance, and then that's how we move the whole shape. So this right here, I'm going to try to replicate this vector from each point, same distance, same direction. So I'm making the same vector, same distance, same direction from each point. And then my new point would be A prime, B prime, and C prime. And then once I translate each point, I can just connect the dots to make the shape. And so this is congruent to the original, just in a new location. We can visually translate a shape, and then here is where it's going to bring in the numbers and show you how to do it with the coordinates. So the first instruction here, it says to graph point A at -3, 2. -3, 2. This is A. And then the next instruction is the graph A prime. And A prime goes at 3, -3. A prime. So this point to this point is like moving this direction. So it says describe the movement from A to A prime. Just saying like diagonally to the right isn't specific enough. So what we do is we say, okay, to get from A to A prime, we would move to the right however many units, and then down however many units. So in this case, it's 1, 2, 3, 4, 5, 6. So right 6, down 1, 2, 3, 4, 5. So describe the movement from A to A prime, right 6, down 5. But if we wanted to even make it easier to write, we just use numbers. So right 6 would be +6 on the coordinate plane, so +6, and then down 5 would be -5, -5. So our translation vector is +6 -5. Or visually, it would be like an arrow like this. Okay, so just as we can move this, so if we saw this vector, we could take the point and count 6 to the right and 5 down and get the new point. We could also use the coordinates and math. So our original point for A was -3, 2, which they have written here. So we can add 6 to the x and then subtract 5 from the y and get our new translated point. So -3 plus 6 would be +3, and then 2 minus 5 is -3. And the way we'd write the coordinate rule is like this. So x, y, the original, comes x plus 6, y minus 5. If we were given these instructions, we could translate our shape correctly. Okay, so the translation rule is xy becomes x plus h and y plus k. H stands for horizontal change and k stands for vertical change. So it's x plus horizontal change, so like right or left, and then y plus vertical change, up or down. So going right would be a positive number, or going left would be like a negative number, and then vertical change up would be positive, down would be negative. And then if you struggle with horizontal, remember like the horizon with the sun, horizon is horizontal. Horizontal line is like this. Okay, and then here is some little sample questions down here. It shows the translation rule. Translates the point 2 units blank and 5 units blank. Well, x plus 2, so that'd be 2 units to the right, and then minus 5 would be 5 units down. And then this one, it says, what is the algebraic description for a transformation that translates the point xy 2 units to the left and 3 units upward? To the left, 2 units would be minus 2, and 3 units up would be plus 3. So xy becomes x minus 2, y plus 3. Okay, and once you have that down, you can flip to the back. And I also added a new translation rule up here as a reminder to the different rules that we're learning. Okay, so back on the back, we are going to now like translate actual shapes. It says the trapezoid JKLM with these vertices, and it gives us 4 points, and the vector is -7, -3. So that would be left 7, so -7, and then down 3. So first things first, we're going to graph these points on the graph, the originals. So J is at 2, 4. Then I put J and just label it. K is at 1, 1. L is at 5, 1. And then M is at 4, 4. Just graphing those points, and then I'll connect the points to make, it told me it was a trapezoid, it looks like a trapezoid, so my points must be correct. Okay, and then I'm going to translate this shape to left 7, down 3. So that means for each point, I'm going to move it to left 7, down 3. 2, 3, 4. Also, instead of counting 7 units, you can use the coordinates. So this is at 1. So if I go to -6, that would be 7. 1, 2, 3. L is at 5. So if I go to -2, that's 7 units. And now 1, 2, 3. L prime. All right, do your work. Who's snoring? David, you're snoring. David. David. This isn't a dream. You're in math class. David. I can't be violent in the classroom. Okay, but stop snoring. Oh. Y'all. Make me work too hard. Well, if you guys are sleeping during the lesson, it's notice a concern. And then often I don't let you do your homework later too. So he's not getting away with it. Just anyways. Okay. So we moved each point left 7 down 3 and we got these new points. Here's our translated shape. Cool. We can also do the same thing with the coordinates. So our coordinates here, I'm going to write them here. So J is at 2, 4. So I'm going to put 2, 4 right here and leave the space off to the side right here. And then K is at 1, 1. L is at 5, 1. And then M, 4, 4. So you can use your vector here, your instructions, and then put them with the coordinates. So minus 7, left 7 would be minus 7 here. And then down 3, minus 3. So minus 7, minus 3 for each of them. And then you can do the math to get your J prime, K prime, L prime, and M prime. So J prime 2 minus 7, negative 5. 4 minus 3 is 1. And I go to negative 5, 1, and yep, J prime is right there. 1 minus 7, negative 6, negative 2. Yep, K prime is there. It's labeled prime. Yeah. 5 minus 7, negative 2, negative 2. Yep, L prime. 4 minus 7 is negative 3. 4 minus 3 is 1. Negative 3, 1. M prime is right there. So you can figure out the points by graphing and counting, or you can use the math with the vector. Okay, we're going to do it again with the next one. Triangle QRS with these vertices. The vector is negative 1, negative 2. So that means left 1, down 2. So points QRS. Q 7, 1, R, S, negative 1, 2, S. Okay, so that's our original, and then we're going left 1, down 2. So left 1, down 2. Q prime. Left 1, down 2. S prime, so I'm just moving each point. Left 1, down 2, R prime. And then here are our new coordinates and our new shape. Okay, and then just like before, I'm also going to do it with the coordinates. So Q is at 2, 5, R 7, 1, and S is at negative 1, 2. And the vector is minus 1, minus 2. So minus 1 with the X, minus 2 for the Y. And then just do the math to get the new coordinates. So 2 minus 1 is 1. 5 minus 2 is 3. Check. 1, 3. Yep, Q prime. 6, negative 1. Yep, that's R prime. Negative 2, 0. Yep, S prime is right there. Okay, and the last one is kind of like a testing style question. Same idea, just a little bit of a different format. It says segment AP undergoes a translation such that A prime is 1, 1 and P prime is 4, 3. What are the values of H and K? So H is your horizontal change. And then K is your vertical change. And then AP here, A prime, P prime, I'm going to graph that. It's kind of tiny. It's not really ideal. P43. A new segment. So for the horizontal and vertical change, you just choose a corresponding point. I'll choose P and P prime, and it's going to the left or to the right a certain amount of units and then down a certain amount of units. I know it's really hard to see it in this paper if you were to count specifically. You could also use the coordinates on here too, but if you were to count, it's +8 and then down 5. So the horizontal change is 8 units, and then vertical change, -5. And then for B, the question again has to do with whether these are congruent or not, and oftentimes the multiple choice will have to do with whether they're congruent. So with a translation, the size and shape of whatever you're drawing isn't changing at all, it's just in a new location. So which of the following statements is true? AP and AP prime have different locations? Yes, that is true. AP and AP prime have different shapes? No, same shape and size, they're congruent. AP and AP prime have different sizes? No, they are congruent. They have different directions? No, with the translation, nothing's turned or reflected or anything like that. So that is the answer. Okay, and there's one more thing that comes up on the homework bank that I want to make you aware of. And it looks like this. So let's see. So parallel lines like this. And it has a, let's say, a right triangle like this. And it says that the right triangle is reflected over 2 parallel lines. That the result is the same as blank. So if you were to reflect this over 2 parallel lines, like twice over 2 parallel lines, reflected once, it would land right here. And then reflect this again over this line, and it would land right here. So reflecting it twice over 2 parallel lines is the same as translating it here. So the same as a translation. Kind of a weird problem, but now you know what they're looking for. And that is all. Okay, so your to-do list is, and you have a good amount of time to do it, is homework 4-2 on Schoology. Alex, if all your homework and 10 Alex are done, you can ask for your phone and show. Okay, ready, set, go.